along the topic of energy is what happens when the energy comes into contact with any particular molecule, and sometimes with a group of molecules or a substance. So the first option is that that energy can be absorbed, meaning taken in. So sunlight strikes your dark shirt, and that energy is absorbed, and you feel it. Energy like sunlight hits a plant leaf, and that energy again is absorbed and used for the process of photosynthesis. Some things also could be talked about in terms of radiating or giving off energy. So when that sunlight hits your asphalt or your black shirt, that light energy gives energy to the molecules of the substance, and then those in turn emit or radiate heat energy. And this can also be coming from another substance. This is also used when we're talking about the energy originating from that thing. Sort of an opposite of being absorbed is being reflected. So energy that hits, sunlight that hits something shiny like metal or ice, that most of that energy is bounced off, so it is reflected. And this is very, very important when we're talking about climate change and whether a substance on the surface of the Earth is dark and absorbs light or is very light-colored and reflects light. And don't forget that for something like photosynthesis, we learned about the idea that what color is reflected is the color that we see. So something that we see as green, only the green light actually got reflected, everything else was absorbed. Something like snow, we can see, and ice, if you're seeing white light coming off that, then that means the entire electromagnetic spectrum pretty much is being reflected, and very little of it's being absorbed, so it's very important. Alternatively, substances could transmit or conduct energy, meaning the energy simply passes through them. So, for example, non-greenhouse gases allow heat from the earth to be transmitted past them or sort of through them. Or we would use the term conduct when we're talking about something like which substances allow electricity to pass through them. So metals, for example, salt water rather than wood. Wood does not really conduct electricity, so electricity does not pass through it. But when we're looking at things like radiating and absorbing and reflecting and even transmitting, one of the things to keep in mind is we've sort of mentioned different forms of energy, and that brings us to the question of what happens in terms of energy changing. So let's take a look at the laws of thermodynamics. Thermodynamics is all about energy in a dynamic or changing form. And the first law of thermodynamics is the idea that energy has to come from somewhere. It can't just originate from nowhere. So nuclear energy, fission, that energy was first stored as potential energy in the nucleus of the atom, and when it radiates out, it's because the nucleus decays. And also energy can't be destroyed, so while we don't notice it after a while, it hasn't actually gone away. It is simply changing form or is so diffuse that we can't perceive it anymore. So changing form is really, really, really common. That's the idea that sunlight gets absorbed by things, and then those things give off heat. That's the same energy, it just changed form from light energy to heat energy. And the thing is, when that energy changes form, the new form is less focused, less able to do work. And so we call that having greater entropy or greater chaos. So sunlight's pretty focused, pretty powerful. The same amount of energy in heat is actually very diffuse, and you can't make it do as much work as easily. And that's a very important concept in terms of how the universe is functioning, but it also can be important for us when we think about the efficiency of different types of energy sources when we get to things like electricity and fuel. So that's sort of the background that you need to know about how energy moves around and how it changes.